In the late 1980s, the management of Lockheed Corporation reached a decision to vacate the huge factory complex at Burbank, where aircraft had been built for over 60 years. The time had come to move the aircraft work to more modern facilities elsewhere. By 1990, people and equipment were gone from many obsolete buildings that had covered more than 300 acres. These included the structures where, in 1928, Allan Lockheed and a small group of employees began making wooden airplanes in buildings once occupied by makers of china and glassware. It was on this site, 4 years later, that the current Lockheed Corporation was born. Lockheed's announcement that most of the buildings would soon be torn down stirred memories among many who had known the company in its early years. One of them was Harvey Kristen, who had joined the company soon after it moved to Burbank from Hollywood. As a teenage student from Pasadena, Kristen took a temporary job at Lockheed in 1928 and stayed on for nearly half a century until his retirement in 1974. Working in many branches of the company, Kristen was an eyewitness to events that took the firm from a fledgling in Burbank to a giant of the aerospace industry.
This is where it all began, our first day at work at Lockheed. To my rear was San Fernando Road and Empire Avenue. To my right, the Mission Glass Company. To the left, the China factory. Behind this venerable brick wall, the China Company had become a very important part of the Lockheed complex, utilized for fabrication and subassembly.
When Kristen joined Lockheed Aircraft Company, it had only 80 employees, some working in this building that had belonged to the Empire China Company.
They were building the Vega, wing monoplanes made of Sitka spruce, and almost in its entirety. Well, since the fuselage, the empennage, the wing, everything but the landing gear and the power plant were made of Sitka spruce, we used principally highly qualified cabinet makers. These men were extremely proficient in following layout drawings, engineering drawings precisely. They made temporary tooling of wood to make ribs, to form the airfoil of the wing. They had a mold that made the diaphragms, the bulkheads, which, by the way, were made of almost 20 to 30 laminations of Sitka spruce. And I must add that at this point, and this is important, a piece of Sitka spruce, 1/4 by 3/4 by 24-inch long, 8 annular growth rings to the inch, free of all rosin or leaks, hold 24,000 psi, laminated into a bulkhead. It pulled 120,000 psi, which is the equivalent of some pretty high-grade chromolybdenum steel. Didn't know that at the time, but we found out later that spruce airplane had the qualities and the strengths of many, many metals, but had the flexibility of a spruce tree.
Leading the small group of airplane builders was a man whose name would become famous in the industry, Allan Lockheed.
Allan and his brothers, Malcolm and Victor, were in on the original group with their chief designer, a man, well-known man, Jack Northrop, who was the outstanding creator of the monocoque fuselage and the type of airplane that the Lockheed Vega and other models turned out to be. A man named Tony Stadelman, who came from Czechoslovakia by way of the Middle West, turned out to be the factory man, the builder, the man who could take all of Northrop's designs and create them into an airplane. These men I just mentioned were the principals of the Lockheed Company that came to Burbank.
Production of the Vega and other wooden aircraft at Burbank was threatened in 1929 when the American economy went into a tailspin.
The Lockheed Company was struggling to maintain its workforce and its capacity, which was minimal. And Allan Lockheed was approached by a group from Detroit who formed Detroit Aircraft, who had hoped someday to become the General Motors of the air, and Lockheed was one of their acquisitions, along with Ryan Aircraft, Parks Air College, and Evans Pump Company, etc. But they no more than established themselves as the new owners of Detroit Aircraft, bringing their executives to our company. And along came a very, very, very difficult time known as the Depression, the Great Depression. So Detroit Aircraft found themselves overextended financially, and they went into bankruptcy. And coincident to that, a far-sighted individual who was a Detroit Aircraft executive and general manager, this plant representative named Carl B. Squire, worked with local people through the Title Insurance Trust Company, and were able to put the Lockheed Company into receivership under California law, prohibiting then the company to be sold off piecemeal and disappear as a name, as an asset of the Detroit Aircraft Company. There were only 3 people in the entire company during the Title Insurance Trust Company and California receivership. Carl B. Squire, who stayed here from the Detroit organization as general manager for them, became the head man of representing the receivers. A chap named Ronald King was the bookkeeper, and a fellow named Harv Kristen was the factory man, handling minor repairs, shipping spare parts, providing spare parts, bringing in crews as necessary by Mr. Squire's orders and the customer's agreement to do major repairs. We kept the plant open on an on-call basis, and we paid, by the way, not by checks, but by cash envelopes, by the hour, by the job. In June of 1932, a small group of investors headed by Robert Gross, including Cyril Chapelet, Carl Squire, Mr. Ryan and Larry Ames, and Walter Varney of the Varney Speed Line, were able to put together $40,000, which seemed to be an appropriate bid at the time for the company. There were others that attempted to consolidate and be bidders, but did not quite make it. Therefore, on the day of the court sale, Mr. Carl Squire, who was going to represent those of us that were at the factory, suggested that I might go down and witness the sale. We took the Lockheed truck. I took the Lockheed truck. We drove down, sat in the rear of the courtroom, very inconspicuously, and observed the following. When Robert Gross presented the $40,000 check to the judge turned to him before closing the sale and said, "Young man, I hope you know what you're doing." And Mr. Robert Gross said, "Yes, sir," most enthusiastically. And with that, the judge hit the gavel on the desk, and sold was the statement. And that concluded the sale out of receivership, but the beginning of our wonderful company that we have today. You know, there was an era in the aviation world when it took a Lockheed to beat a Lockheed. And when better airplanes were built, we said, Lockheed will build them. And that's when the Vega brought the good name Lockheed into the limelight as the most reliable, best performing, highest cruising speed, best fuel consumption airplane flying in its day. Famous pilots, Wally Post, who flew around the world on 2 occasions, once with a navigator and once alone, and then broke the record for high altitude performance with a flying suit of its day, the forerunner of today's astronaut suits, by making a little red Vega that normally cruised at 150 miles an hour, cruise at 350 from our Southern California to the East Coast. Other than Wiley, there were famous pilots such as Roscoe Turner, who flew for Gilmore Oil Company. He was a flamboyant type of a pilot, but he brought great credit to our airplanes, both the Vega and the Air Express, which became the Earl Gilmore Oil Company airplane, where he, as his mascot, carried the lion Gilmore. Other pilots, such as Sir Charles Kingsford Smith, who flew the Pacific in a Lockheed Terror. And then there was the Magyar brothers, who flew the Justice for Hungary from New York to Budapest, bringing to the attention of the world the freedom for Hungary. Well, Jimmy Doolittle came to us as a bit of a hero because he had made the first flying landing in Dayton, Ohio under a hood. Had never been done before. Complete landing without sight of the terra firma. When Jimmy Doolittle acquired his Lockheed Orion, a derivative of the old original Vega design, he was the research pilot for the Shell Oil Company. By 1934, the company had made the management decision to proceed with this new Electra Model 10. And it was built assembled primarily in the hangars that were left here by the old original Lockheed Detroit Aircraft Company. Final assembly, if you please, outside of the hangars because the hangars are not big enough to take on the wings of the airplane and the assembly. From there, they proceeded to our own little flight line along this railroad strip, not yet anything but a dirt runway. And from there, the initial Electra flew and was tested and accepted by our then chief test pilot, Marshall Heedle, and a pilot on loan from the Boeing Company. The reports on this new twin-engine all-metal version of the Lockheed airplane began to come back from Michigan, recommending the abandonment of the single fin and rudder and the adding of the double tail, the twin fins and rudders, for directional stability, for single-engine outperformance. And that was accepted on the spot. And as a result of that decision, that became the hallmark of the Model 10 Electra, this double tail. And it was recommended by none other than Clarence L. Johnson, who very shortly became the chief aerodynamics of our present company. During the 1930s, some very interesting and famous pilots came by to evaluate our Electra because of its very, very high performance characteristics, and especially its single engine performance and its long range. Amelia Earhart was another one of those famous and wonderful persons that we got so well acquainted with because when Amelia came to acquire her first little red Vega, as she called it, she put on a pair of Lockheed coveralls and went out in the shop and worked next to the woodworkers and the cabinet makers and then the final assembly and went out on the flight line as part of the crew and was a most gracious lady and a most appreciative lady because she knew when she flew her airplane, almost every nut and bolt of any importance as it was assembled, her confidence factor was improved immensely by the fact that she was a part of the building of her little red Vega. And naturally, we were so proud of her because she flew the Atlantic alone and was quickly named Lady Lindy. When she flew the Atlantic, she, of course, landed in Londonderry, Ireland. And the people, of course, that were most gracious and most appreciative of her wonderful accomplishment. Later on, in years to come, we had another great experience with Amelia when she came out to personally become involved, just as she did on the Vega with her Model 10E Electra, that it was very specially built for her because She was going to carry approximately 1,100 gallons of fuel. She was going to have special navigation equipment. And in the process of building her airplane, once again, she put on coveralls and became especially involved in what we called our QEC, our power plant installations. In fact, I can recall her help plumbing and the engine installation, because she wanted to know firsthand how and where the fuel, the electrical power, everything came from in the power of the airplane, knowing full well that with two engines, she'd need them both with the heavy load takeoff that she was about to make on the round-the-world flight. In other words, once again, Amelia became part of our crew, part of us, in the process of building an airplane. Another demonstration of a great pioneer and a wonderful lady. Then there was Charles Lindbergh and his wife Anne, who frequented our place daily almost during the process of the building of their Cirrus. We built it, of course, as a fixed-gear land plane, but knowing in the final analysis that he was going to do a route survey of the Pacific for Pan American, but that Cirrus that he and Morrill Lindbergh acquired was very special because we put a canopy on, we put things on to protect them from the elements, because Anne became his navigator and his radio operator. Just think of it. Here's a lady that just never had an experience like that until she married this wonderful pilot, this wonderful fellow, Slim Lindbergh. They eventually, of course, put floats on the airplane. And testing that airplane, which we'd never put floats on before, was quite a unique experience. Again, the center of gravity, fuel loading, and the takeoff characteristics of a seaplane, so different than a land plane, caused us to go through some very interesting, we call them high taxis. And of course, to get a float up on the step, you almost have to have a turbulent sea. A smooth sea gets you nowhere. Lindbergh knew that. And they used to go ahead of him when he tested with a high-speed boat to create the turbulence in the waves and the water in the wake of the boat to help him get the vacuum broken under the steps of his floats. What an experience it was for us, because we had never built a low-wing Cirrus seaplane before. Yet another wonderful experience was to have this great pioneer, most enthusiastic aviation man named Howard Hughes come to our plant with a little Boeing P-12 and ask Kelly Johnson and our engineers and Mr. Gross if we could modify it and turn it into a high-speed racer. It turned out that it was my good fortune to be in charge of that project. And we had a no-holds-bar latitude. We could get anything, anywhere we wanted at any time. We stripped the fabric down to the bare tubular skeleton. And with a little skill and special engineering, we were able to make it into a monocoque-type shaped fuselage with sheet metal, streamline it, put streamlined gear, landing gear on, add a terrifically heavy-duty, high-powered power plant, compensate the center of gravity for Howard. And we accomplished that in weeks, not months. And following that, we had the great experience of Howard selecting the Super Electro, we call it the Model 14, to fly around the world. And of course, that took special handling with regard to fuel consumption, fuel capacity, navigation gear, navigation equipment. And in 14 days plus, I believe it was, he made the round-the-world flight and very successfully demonstrated that transport equipment, commercial transport equipment, was able to make some of these extended hops under controlled conditions.
In the 1930s, before Lockheed had any facilities at the nearby commercial airport in Burbank, The company did all of its flying from a dirt runway between Empire Avenue and the railroad tracks.
This is the site of the original 2,000-foot dirt runway, gopher holes and all. It's from this very runway that the famous Winnie Mae of Wally Post, Amelia Earhart's Little Red Vega, Sir Charles Kingsford Smith's Altair, Lindbergh's Cirrus, all of them flew from this very runway.
In the late 30s, war broke out in Europe. The British had an urgent need for new aircraft. Lockheed offered to build a new bomber.
During that period, we had expanded the design of the Electra into what we called the Model 14, which was an enlarged semi-mid-wing version of a twin-engine, two-tail airplane. And at that particular time, the British were interested in getting support in the form of a patrol airplane to protect the coast of all of the British Isles. They came to the United States and reviewed the designs of our aircraft and others, competitors. They chose the Model 14, which we, in a 24-hour period under Kelly Johnson's supervision, converted into a mock-up of a Hudson bomber. And this is a very, very important area of the original Lockheed as we know it today. This is where Robert Gross's executives presided in their offices we knew as Mahogany Row. Also, this very spot, and through a switchboard right up in that corner, came the word from London, England, from Cortlandt Gross to Robert and his team that the Hudson bomber contract, up to that time the largest contract ever given to anyone in these United States, was consummated. When we received that order, immediately we had a procurement program established that was second to none, with the organizations such as the Aluminum Company of America and the engine manufacturers, because 200 Hudson bombers in one initial order never had come to any company in that quantity before, on a schedule that was so uniquely developed to meet British requirements. And the next requirement became, where are we going to build all these airplanes? So the company could only expand in one direction because Burbank was on the east, and that was it. So westward we came. We closed off a street called Lincoln Avenue and moved all the way up to Buena Vista, which is a offshoot of San Fernando Road and Turkey Crossing, where the little plant first started. As production accelerated and we were beginning to accumulate airplanes in our test area, and by the way, our test strip was the old dirt runway at B1. We did not have a paved runway, no lights, no traffic control. We were the traffic control by way of the pilot house, as we called it, right at the edge of that little runway at Burbank. And that's where the Hudson started his first testing, his first flying. You know, during the midpoint, or as we became quite well established on our Hudson line, along come a design competition that Kelly Johnson entered for Lockheed. Turned out that it became Lightning, the twin-tailed P-38. So what we did is we divided the assembly line into a Hudson line and a P-38 line, and started the P-38 line down through the same general overall assembly building, paralleling the Hudson bomber. The rate of the P-38 was slow and accelerating initially, but we got it up to where many P-38s a day came off that line, even faster production schedule than the Hudson. The P-38 program probably accelerated faster than any line in the area. We got to a point where we were able to roll a P-38 in an hour. But we had control over the condition of those airplanes to the extent that you could pick any airplane and decide what the status was and bring it up to flight status immediately upon receipt of whatever the requirements were that were missing in the assembly line. We had absolute control. The result was very few run-up failures or test flight failures. We had quality control by pride of workmanship and by a group of people who knew by experience on the Hudson line how to handle the accelerated program on the P-38. So the Hudson program became a very, very invaluable or valuable program for developing our skills to take on a dual assembly line at the time. The Hudson and the P-38 required no end of additional skills in piloting our airplanes, and we brought in some very, very famous people who maybe at the time were not, but became so important to the Air Force and to ourselves. To name but a few, Milo Burcham, who had flown with a group in a Boeing P-12 at air shows and had the skills that came with aerobatics and acrobatics and knew how to recover an airplane from test flighting conditions that you deliberately put the airplane through. So Milo became a very key figure. When Tony LeBeer came on board, little did we know that he was to bring that very unique skill. To Tony, the impossible was just a little more difficult. Tony was able to do things with the P-38, as was his partner, Fish Salmon, who became famous also. They literally flew test flights, monitoring each other, confirming each other's results, which was a rather unique condition. Tony would take a P-38 up and ring it out, go into a flat spin, do the impossible recoveries to satisfy Kelly, to confirm that not just one man could do it. Fish Salmon would go up and repeat the performance. All the while, Milo, who was chief pilot at the time, was biting his fingernails, hoping these two fellows didn't tangle, because sometimes they'd go up and literally do what we used to call combat-type maneuvers with each other. Right about the time that the P-38 and the Hudson were going full swing, there was a need for second sources of some very prominent and very important airplanes, and one of them was the B-17. So all of a sudden, there became a subsidiary that had already started in the old China factory at what we call the old Lockheed Company as a design group with Max Short and a few important people that came from the Stearman Company. This fully owned subsidiary was known as the Vega Company, very proudly, because the Vega, in its early days, as you know, made the name Lockheed quite famous. So as the Vega Company came into being as the second source for the B-17 program designed by the Boeing Company, it became the number one second source, the other source being Tulsa, Oklahoma, run by the Douglas Company. The Vega Company built the facility around the assembly lines as they developed and the fabrication shops developed, expanded as the airplanes were being built and assembled, literally built the buildings over the workforce. This excellent facility of its day, built on the southeast corner of the airport, was to become the home of the Vega Company, a wholly owned subsidiary of Lockheed. One of the unique things about the Vega Company was when the Boeing Company had a challenge that would come from the Air Force to modify a B-17, the request would go out to the two subsidiaries. The first chin turret to protect the nose of the gunner and the nose of the airplane and the crew was a Vega installation. And I remember well going to the Long Beach staging area where we took our P-38s and Hudsons that were flown into the Pacific Theater the Hudson to Australia, the P-38s into the General Kenny's work task force. That when a B-17 showed up at Long Beach with a chin turret on, you watched the ferry command. They'd come out and walk up and down that line. And when they saw a chin turret on the airplane, that was their baby, because not a one had to be ditched in the drink. The Vega B-17 line, as we knew it, was built in the facilities adjacent to Hollywood Way, and literally in a facility that wrapped itself around the then Lockheed Air Terminal. And they successfully produced well over 2,000 B-17s on schedule to the latest Air Force requirements with a quality standard that made them second to none. You know, about that time, Pearl Harbor, you know, the scare of the submarine off of Galita, there was a scare that came across the entire West Coast. Shipbuilders, airplane builders, anybody that was vital to the defense program had to have the ultimate of protection. And somebody came up with the idea of camouflaging our plants. And you know, this was quite an experience, because once again, all the trusses and all the cables and all the support structure had to be built over our heads as we were building airplanes. And the part that was so darn messy was the fact that they used chicken wire, as we called it, to stretch over these buttresses and cables and so forth over our plant. And then what did they do but blow feathers with an adhesive, waterproof adhesive, onto these wires? So we were picking chicken feathers out of our airplanes, out of our hair, all at the time we were building airplanes. But believe it or not, when we found out through aerial shots of what our plant looked like from the air, we suddenly discovered we were a little community of houses and business buildings that somehow or other, the giveaway only that we detected was the fact that a railroad track ended and began in the middle of this little community that was called camouflage. Right in the middle of this intense production program, our great Kelly came up with another dream. Because suddenly there'd become available in England an engine designed by a Mr. Whittle. It was called the Whittle turbine. And while that was going on, Kelly had already designed on paper how he was going to apply that little engine and that thrust to an airplane. That airplane became known as Loughead. It was built in tents. It was built in little buildings that suddenly became vacated and available, and then became secured and fenced off. And suddenly out of that little complex came drawings. We who were building the production airplanes suddenly became aware of a drawing that would come out for a forging in a part that had a peculiar name, like McCormick Deering Tractor. Had no relationship to an airplane, to keep the design secretive. And when that went out to a forging company or whoever it was that made that component, they were put in a position of not needing to know. And that was the key. Unless you had a need to know, you didn't ask questions, you didn't become involved. So as Kelly built Loughead in a record 143 days, towed it up to then Muroc Dry Lake, now Edwards Air Force Base. And again, here comes that wonderful guy, Milo Burcham, who was elected to make the first flight in Loughead. Loughead flew, was very successful. The thing that Milo said, gosh, it maneuvers well, it's fast, and it gives you a feeling of confidence.
The flight of the XP-80 in 1944 launched Lockheed into the jet age. This design would evolve into America's first production jet fighter, the Air Force Shooting Star. While the first flights were being made, a new building was under construction on Empire Avenue, where the Skunk Works team would begin production of P-80s.
This is the famous cotton shed, built and patterned after the cotton bale storage places of the South. It was where the YP-80s were built, which were the forerunner of the production version, the P-80 Shooting Star. In the middle of the YP-80 project, there came a very special assignment. Secretively, we were to put slipper tanks out on the wingtips.
The wingtip fuel tanks gave the P-80 enough range for combat missions. The Burbank plant built over 1,000 P-80s. In the 1950s, they served in the Korean War and elsewhere around the world. Just before World War II, Lockheed had designed a large new transport. It was given a name that would become widely known.
The name Constellation became a famous name in our company, and we always named our airplanes after stars or constellations of stars. And the Cirrus was a star, the Vega was a star, the Altair was a star, and along comes the need for a bright and shiny new airplane that had the benefit of all those that had gone before, and it became a Constellation. And its nickname was the Connie. It was one of those unique experiences where a customer, naturally, in those days had to be found for their first group. Well, the customer turned out to be TWA, owned by none other than, at that time, our friend Howard Hughes. So as Kelly Johnson and his design staff and Robert and Cortland Gross and Howard Hughes would meet, they would draw and submit ideas of what the configuration should look like. Well, one interesting experience, and this is a factual experience. The first design that came up was a typical, very straightforward cigar-shaped fuselage. And it had a multiple tail, but it didn't look like what the Connie turned out to be. Mr. Gross looked at that airplane, as did Howard and the rest, and it was a very efficient-looking, straightforward design. Every section of that fuselage is identical. It was ideal for production. But Mr. Gross says that airplane doesn't look like it really wants to fly freely. Why don't we do this? He walked up to the blackboard and he drew a couple lines that looked like a side view of a dolphin. And Kelly looked at that, and Howard looked at that, and they said, wow, if we do that, technically the fuselage becomes an airfoil because your shape is like the wing rib of an airplane wing. So all of a sudden, right then and there, in spite of the need for standardized production, we had a multiple shape design that, of course, made new bulkheads at every station and made it a little complex initially. But oh, how it contributed to the reputation of that airplane.
The first Constellations came off the Burbank assembly lines during World War II and served as military transports. At war's end, commercial airlines would begin ordering Constellations. Eventually, they would be in passenger service around the world.
To see it in the air was to see the most graceful airplane. And that Connie became the flagship of Pan American, Eastern Airlines, Chicago and Southern that became Delta, and many airlines in the European theater. Even Qantas Airlines down in the South Pacific, they put drop tanks, dip tanks on the wing extended the range and made it look almost like a version of a military airplane, but it still had the grace of a Connie. And that airplane was, in a commercial sense, the airplane that took us into the next generation of Lockheed airplanes.
The military Constellation assembly line was one of many production lines that operated simultaneously at Burbank during World War II. Employment grew by the tens of thousands to meet wartime schedules.
The employment grew so fast, keeping head count was a near impossibility for us in the factory area. In fact, it wasn't our responsibility. We made the demand the requirement. The personnel department brought them in and trained them. We certified them as being ready to go. We had a last word to say he's ready or send him back for a little more, give him a little more help. But in that process, all of a sudden, including our outlying plants as far away as Bakersfield, Beverly Hills, believe it or not, the old Ford motor plant called B2, the old Willys Overland plant in Maywood, where we made our drop tanks for our P-38s. All of those airplanes and all of those called for the maximum effort on personnel and training. At that point, we passed well over the 90,000 mark. In fact, some of our people will insist that we did reach the 100,000 mark. Conservatively speaking, I would say 90,000 plus. From a little company that, remember, started in 1928 with 80 people.
Many women joined the wartime workforce.
Yes, oh, the women came into Lockheed. They reached a peak of almost 40% of our production workforce. They particularly adapted well to precision work. Their fingers were more nimble. We were all thumbs. They could put an instrument panel together. They could assemble wiring bundles to install as a unit into the airplanes. They could assemble hydraulic units very precisely. They adapted so beautifully. And we brought that term out at the Vega company called Rosie the Riveter. But believe it or not, Rosie the Riveter was a symbol, but the riveting was one of many, many skills that they brought to our company.
During the war, the company's Burbank facilities had expanded to cover several hundred acres. Factory buildings spread for half a mile east and west of the old China Company quarters at Empire Avenue and San Fernando Road. A mile to the west, another factory complex had been created for B-17 and Constellation production. By 1945, the Burbank factories had built almost 19,000 combat aircraft for America and her allies. When the war was over, Lockheed continued production of Constellations in commercial airline as well as military versions. The company and its Vega subsidiary also began designing new aircraft, including one for the Navy's anti-submarine patrol missions. It was named the Neptune.
They wanted it to be compact, not cumbersome, small by comparison. So they come up with the idea that it would be a two-engine airplane with a tremendous fuel capacity to stay on station and yet have the ability to carry the payload that was required. And it had to have some unique features never before installed. For instance, it required a magnetometer that heretofore had been used in the oil industry to find and locate oil fields, which was a device that was attached to the airplane. It looked like a stinger. And so the U-2 Neptune was the second breath, you might say, of the beginning of the very successful career of the Vega Airplane Company and its contribution to the services. And another version, Operation High Jump, South Pole Expedition. Suddenly, we got the request to develop a ski airplane. Well, it come out that it wasn't just one. It was a sequence of ski airplanes, backup airplanes, where the Navy was going to go to the South Pole and do some exploratory work. Another very important contribution that P2V was made to the Navy and to our services and to our country was the fact that it demonstrated that it had the ability to stay airborne for hours beyond any aircraft up to that point. To demonstrate that, a commander took an airplane and designated the truculent turtle. What a name for an airplane that performed like the P2V. He flew that airplane nonstop from Australia to Columbus, Ohio. And incidentally, when he landed, he played it safe. He had enough fuel on board. He could have gone to the Navy base in Washington, D.C.
During 16 years, starting in 1946, the Burbank plant built more than 1,000 Neptunes in many versions. The P-2 also was built by the Japanese under license from Lockheed. The factory buildings expanded in the 1940s to produce a variety of aircraft types, including one that would become the biggest airplane ever built in Burbank. Its assembly would require Lockheed's largest building in Burbank.
In the mid-1940s, Lockheed was fortunate enough to be contacted by the Navy to develop a heretofore never designed or built aircraft known as the Constitution. It required a very special hangar. We called it the Constitution hangar because it had to have a clearance for that fin on that Constitution of 6 stories. The cockpit, in fact, was 3 stories above the ground. This facility hereafter was known as the Constitution hangar.
Designed to take off at a maximum weight of 92 tons, the Constitution needed turbine engines. Because turbines were not yet available, the 2 prototypes began their test flying with piston engines of 3,000 horsepower each. The mission was to transport Navy personnel and their equipment, as well as a senior officer in an airborne command post.
Took the initial first number, serial number 1, to Patuxent River. And to the amazement of the Navy test pilots in the program down at Pax River, this airplane did things that no other airplane had ever done. And why? Because for the lack of the turbine engines, we installed JATO bottles integral to the wing. And we could take that airplane off the ground with the equivalent of 5 engines in power. Each of those JATO bottles developed 1,000 pounds of thrust for 14 seconds. And when you put 16 turbine valves, 8 on each side, 1,000 pounds each, suddenly you had 16,000 pounds of JATO thrust.
Lack of power kept the Constitution from full production, but the prototypes were forerunners of huge jet transports that would fly 20 years later. By the mid-1950s, turboprop engines were available. Lockheed began producing a new commercial airliner, the L-188 Electra, using Allison T-56 engines.
It was a unique engine because it was a turboprop with a gearbox, but it had 2 speeds. It had a ground idle and it had a cruise. So our L-188, known as the Electra, and our C-130 known as Hercules. The Hercules being developed in the Skunk Works, almost parallel to the Electra being developed in our production line. Of course, also demonstrated through our flight engineering group, which was closely tied to our Skunk Works operation because we were using the same power plants. We come up with this unique development where we could give to the airline commercially an airplane that could get in and out of facilities that no other, even reciprocating engine, in some instances, could handle, because of its unique ability to use maximum power with a constant speed engine. So the L-188 became a forerunner, of course, of the pure jet airplane, and airlines like American and Eastern flew that airplane and got maximum performance out of the airplane.
The arrival of the pure jets brought an end to Electra production after only 170 sales. But the basic design would soon lead to a new naval patrol aircraft that would remain in production for decades.
As the transition from turboprop to pure jets come along, and the Electra line had served its purpose during that transition period, we had an airframe, we had a hull, so to speak, that had many potentials. And we had a power plant that had obvious growth, and it became the Navy version of the L-180H, which is known as the P-3 Orion, or the P-3 ASW aircraft.
Lockheed built more than 500 P-3s at Burbank before production was moved to other facilities. The Orion became the principal maritime patrol aircraft of a dozen nations. At Burbank, new ideas led to additional designs that were built at other Lockheed facilities. The Skunk Works P-80 fighter evolved into a two-seat trainer, the T-33. Over 5,000 were built at Palmdale for air forces worldwide. In the 1950s, a need for a long-range, very high-altitude reconnaissance aircraft inspired Kelly Johnson and his team to design the U-2.
There was an airplane that had to be able to develop an ability to go out of the range of then known missiles, altitude-wise, and have a range, fuel consumption-wise, that was more extensive than even our long-range ASW-type airplanes that were designed for long range. So they come up with a unique airplane with a very slim glider-type, soaring glider-type wing, with a bicycle landing gear, a couple outriggers, a very reliable power plant, and a set of instrumentation that could sense and do a reconnaissance job that had never been done before.
Working closely with Johnson on the U-2 and later on other key programs was Ben Rich, who was to become head of the Skunk Works when Johnson retired. America's first Mach 2 fighter also emerged from the Skunk Works in the 50s. Over 700 starfighters were built at Palmdale, and 2,000 more were produced by foreign manufacturers. In Italy, production continued through the 1970s. By the early 60s, the huge Constitution hangar at the Burbank Airport was shrouded in Skunk Works secrecy. Inside, a radically new aircraft was taking shape, fabricated mainly of titanium. Much later, it would be revealed to the world as the SR-71 Blackbird. In 26 years of service with the Air Force, SR-71s gathered reconnaissance data while flying over trouble spots at altitudes above 80,000 feet and speeds over 2,000 miles per hour. The Blackbird set world records for speed and altitude that designer Kelly Johnson predicted would be long-lasting.
I think it'll be a long, long time before we have an airplane that has higher performance than the SR-71, because the need for it is not there in terms of the fact that we can have satellites circling the Earth in 90 minutes, and we do not have to go any faster than what we go with this one right here, and it'd be very, very expensive to go Mach 4 or faster. So we may be seeing here the highest speed military airplane that there will be around for a long time.
In 1969, Lockheed received a Navy contract to develop a new anti-submarine patrol aircraft that would operate from carriers. Production soon began at Burbank.
Coincident to the production of the P-3 and as a parallel and a new development came an onboard carrier type, a two-engine anti-submarine warfare airplane that had multiple missions even beyond the basic ASW, as a tanker, as a support aircraft for the PS-3 fleet, which accompanied the carriers. That airplane is in operation today and with modifications has been updated to concurrent requirements of the Navy and will be known as the first ASW-type Lockheed-built carrier airplane. In the 1970s, we came into the wide-bodied jet field with a high-capacity L-1011 TriStar, an airplane that was so far ahead of its competition design-wise and capability-wise that it became another hallmark of Lockheed achievement. It was fabricated, sub-assembled in Burbank. The assembly line and the delivery operation was at Palmdale in a new facility built primarily for L-1011 production. The airplane, even today, is in use in various parts of the world, and you hear of it having new duties to perform by new operators, new challenges, and it'll be around for a long time as a standard.
The last airplane Lockheed built at the Burbank plant was completed in 1990. It was an F-117A stealth fighter, produced in secrecy like many of its predecessors by the Skunk Works.
Now, this stealth fighter, as it turns out, will be the very last complete, total design, fabricated, built, assembled airplane on our Burbank property. It will have, for its lifetime, the signature of Ben Rich, endorsed by Kelly Johnson. And by a strange coincidence, I must add that the wingspan of that little F-117A stealth fighter is exactly the same wingspan of the original Lockheed Vega, 42 feet. Just to harken back to the genesis of Lockheed, the incubator days of the old plywood Vega. And I'm sure Ben would acknowledge that the chain of development and the heritage of Lockheed has inspired him, as it has all of us, to continue to come forward with the best that there is that Lockheed has to offer.
Within months after production was completed, Air Force stealth fighters were flying combat missions in the Middle East, writing another chapter in Lockheed's development of advanced airborne technology. Among the facilities vacated in 1991 was one built in 1941 that was used for decades as headquarters.
This building, just across the street from the airport, served as the headquarters, the home, and the heart of Lockheed. It was first or initially occupied by the Vega company, followed by the Lockheed California company, then the corporate headquarters, and finally is the home of the Lockheed Aeronautical Systems Company. This building was the headquarters of our pioneering chairman of the board, Robert Ellsworth Gross. Robert Gross was a great visionary. He saw the potential in the future of our company. He was followed then by his brother Cortland, who Robert Gross always gave credit to for the man that got the job done. Cortland then was followed by an outstanding young man who came to us from outside the company. His name was Daniel J. Houghton. Dan brought a broad experience in leadership and in his strengths that came naturally to Dan, of bringing people together to execute a common project or objective. Then he was followed by a man from outside the industry, Robert Hack. He carried us through a very difficult transition period. He saw the strengths in our company, and he pointed out to us those areas where we could be even stronger. Roy Anderson came to us with a financial background out of Stanford University. Roy brought to us his abilities to select and develop people and put a team together. Roy then was followed by the last chairman of the board to occupy this now famous building. His name is Larry Kitchen, a fighting Marine. Larry didn't know how to use or spell the word quit. Larry was a man who got the job done and who put the team together and developed a common objective.
Corporate headquarters moved from Burbank to a new location in 1986, and soon decisions would be made to vacate the once bustling manufacturing buildings as well.
Change, it goes beyond our changing of our product. It goes beyond the changing of our facility requirements to keep up with technology. Therefore, when we restructure our company to meet the changing times and the ambient environment or conditions we work under, both contractually, both market-wise, both and our product lines, we must be sure that to survive as a viable company ready to take on new and yet unknown responsibilities will require us to accept change as gracefully as we can, knowing that in some instances it could be a hardship. On other instances, and these are the ones I like to think about, they create new opportunities. I'm reminded of one statement that goes with just what's happening today in our restructuring of our company and our facilities. It's Robert Gross's statement. He said early on, when you work in the field of the air, you instinctively look up, not down. You instinctively look ahead, not back. You look ahead where the horizons are absolutely unlimited. And looking ahead is what we must do today, and accept change and accept the need to grow and to take advantage of the changing times and the opportunities they make available to us.
Harvey Kristen returned to the old plant site for a last look at the vacant buildings where Robert Gross had his original office at Lockheed.
These 50 years of association with our dear Lockheed has been an adventure in friendships and relationships of the greats of our company and the greats who flew our airplanes. This then teenager will cherish those memories forever.
He decided he wanted to design aircraft when he was 12 years old after reading Tom Swift and his airplane. He designed his first plane before he'd ever seen one in person. When he first applied for a job at Lockheed, the company turned him down flat. He got his master's degree in aeronautical engineering and returned, and was rewarded for his persistence with an $83 a month job as a tool designer. By the time his career at Lockheed ended 47 years later, he had built the most important aircraft research and design facility in the world. There, in Lockheed's legendary Skunk Works, he and the team he led revolutionized aviation. For 30 years, it was impossible to see a significant display of American aircraft without seeing something Kelly Johnson had designed. Whether it was a fighter, bomber, transport, passenger liner, or even a spy plane, the odds were that he had designed at least part of it. Without question, he is the greatest aircraft designer in history. He is Clarence Kelly Johnson. Clarence Kelly Johnson was born in the town of Ishpeming in Michigan's Upper Peninsula on February 27, 1910. The son of Swedish immigrants, he got his Irish nickname from schoolmates after he stood up to the school bully.
He had been dealing with some of the kids at the school calling him Clara, since his first name was Clarence. And he finally had his fill of it and decided to take reprisals on one of the bullies. And after he was finished, the kids in the schoolyard decided that he could no longer be a Clara, and instead they were going to find some more appropriate name. And since Irishmen were known at that time for their pugilistic skill, they decided to dub him Kelly.
He designed his first airplane, which he called the Merlin Battle Plane, as a 12-year-old, and it won him a prize at school. He knew then that was what he wanted to do with his life. He paid $5 for his first flight, a 3-minute trip in a biplane that ended badly when the plane's engine conked out at 700 feet. When he got older, he worked in construction and in the Buick factory and saved his money. He took his savings to a flight school and asked to be taught to fly. The flight instructor, a cash-strapped barnstormer, refused Johnson's money and told the young man to spend it on college. Johnson enrolled at the University of Michigan just before the stock market crash in 1929 and supported himself washing dishes in fraternity houses. As an assistant in the aeronautical engineering department, he worked with the school's wind tunnel. The school allowed him to rent the tunnel out when it wasn't in use. Johnson charged $35 an hour and helped design a new, streamlined Studebaker model. He graduated in 1932 and tried to enlist in the Army Air Corps, but was refused. He returned to Michigan for his master's degree and, among other things, used the Michigan Wind Tunnel to help design aerodynamic racing cars for the Indianapolis 500. In 1933, he went to work for Lockheed in California as an $83 a month tool designer. Lockheed at the time was a deeply troubled company. It had just emerged from bankruptcy and had bet its future on the Electra, a 2-engine transport. When Johnson arrived in Burbank, his boss asked him what he thought of the plane. Johnson looked and said it would be unstable and that he did not trust Lockheed's wind tunnel tests. Chief Engineer Hall Hibbard sent Johnson back to Michigan with a model of the Electra and a mandate to do his own study in his own wind tunnel. "See if you can do better," Hibbard told him. He did. After 72 tunnel tests, Johnson came up with a newly designed flap system and traded the Electra's single stabilizer for a twin tail. Those changes stabilized the Electra and helped make it one of the most successful airplanes of its time. Johnson returned to Lockheed a full engineer. Assigned as the Model 10 Electra's flight test engineer, he at last started flying on a regular basis. He befriended Amelia Earhart and advised her on several of her missions. She flew an Electra, and Johnson advised her on techniques of fuel mixing to help her get the best performance out of her plane. He continued to work on updates to the Electra through Electra Model 14, and was soon attracting attention outside of Lockheed. In 1937, he won the Sperry Award for Outstanding Achievements in Aeronautics by a young man. That same year, Congress passed the Neutrality Act. That law was designed to keep the United States out of World War II. At the same time, those in the military had become convinced that American involvement in the war was inevitable. They threw as many of their precious dollars as they could into the design of new equipment. Lockheed won the competition to build a new fighter with a plane designed by Johnson, the XP-38. With two engines and a double fuselage, it was an unconventional aircraft that had its share of problems. In particular, its high speed and tight maneuvering sometimes created forces so great that they shattered the plane in midair. Once again, Johnson went back to his wind tunnel, and after making a few changes to the plane's design, it passed Army Air Corps muster and was ordered into limited production. Johnson, the designer, was 27 years old. In the late 1930s, Lockheed came back from bankruptcy largely on the strength of its commercial aircraft. The Electra in particular had built a profitable customer base. But if Lockheed was going to grow, it was going to have to build a successful military aircraft business. The P-38 was a start, though when the Army Air Force first awarded the contract, no one knew how many thousands of planes would eventually be built. In 1938, with Europe on the brink of war, the British sent a purchasing commission to the United States in search of military aircraft, particularly a long-distance coastal patrol bomber that could be used to hunt submarines. The commission, scheduled to visit several aircraft manufacturers, did not originally intend to visit Lockheed. Their schedule changed at the last minute, and Lockheed was invited to make a presentation, with only 5 days to prepare. During the 5 days of preparation for the Brits, Johnson showed what he was destined to become famous for: the ability to make something entirely new out of existing components, and to manage a project to completion with a ruthless eye to the deadline.
He himself lived by the credo, be quick, be quiet, be on time. He was somebody who believed very much in getting good people and giving them the ability to do what they do best. He also believed in minimizing the number of people working on any one project.
In only 5 days, Johnson and his crew not only redesigned the Electra to fit the needs of the Royal Air Force, they also built from scratch a full-scale wooden model of the plane, a civilian transport converted into a medium bomber. The Brits were amazed. They were so impressed by Johnson and his crew, they invited Lockheed executives to England to confer with the Air Ministry. Johnson went along. At the meetings, the British changed the design specifications, necessitating a complete redesign of the aircraft. Johnson locked himself in a London hotel room and in only 72 hours completed the engineering drawings. The British were, once again, amazed, and Lockheed got the contract. But not before the British expressed their hesitancy about working with an engineer as young and inexperienced as the 28-year-old Johnson. Lockheed reassured the Air Minister, who ordered 200 of what became known as the Hudson bomber. It was the largest single order of aircraft ever received by an American manufacturer. And upon the party's return to the United States, Lockheed promoted Johnson to chief engineer. In 1939, the Congress significantly increased the defense budget, and P-38 started rolling off the line in record numbers. During this period, Johnson truly mastered the art of manufacturing, streamlining production processes, and developing an entirely new job, the program manager. Now a staple of manufacturing, the program manager is a person far down the chain of command who has working control of a project. If that all seems a bit heavy on the business administration in a discussion of aircraft, consider this. Johnson believed that outstanding aircraft designed and manufactured quickly were inevitably the product of a single visionary. That visionary was usually, of course, Johnson.
He was not someone who believed in development via committee. He was also somebody who hated lengthy reports and normally limited any report that was sent to him to 20 pages. He believed in brevity, he believed in clarity, and he believed in giving people the tools necessary to get the job done.
In 1943, Lockheed put Johnson in charge of advanced products research. setting him up on a plot of land on the outskirts of Burbank, California. Johnson called his new kingdom the Skunk Works, after the still in a cartoon strip, Little Abner, that was responsible for the making of a mysterious and powerful brew called Skunk Works.
In the Little Abner cartoon, there was a potent mystery elixir known as Kickapoo Joy Juice. And Kickapoo Joy Juice was made at the Skunk Works, or Skunk Works, as it was called in the comic strip, through a variety of things that were thrown into a giant mixture, among them skunks, old shoes, and things like that. And the nickname was applied to the Lockheed operation because, indeed, it was a mystery elixir. Nobody was quite sure what was going on in there, but they knew that a lot of things were being thrown into it and that Kelly Johnson was pulling a lot of people from various locations in order to create something interesting.
The job of the Skunk Works was to quickly, cheaply, and secretly develop advanced aircraft that could help win the war. Its first assignment was the P-80 Shooting Star, the first American jet. Intelligence had determined the Germans were far along in their development of jets, and the not-so-secret fear of the Army Air Force was that the Nazis would deploy their jets in large numbers before the war in Europe had ended. The effect on the Allied bombing campaign would have been horrendous. The Allies' propeller-driven fighters would have been almost useless against a jet-powered fighter.
Kelly Johnson, in his efforts to oversee those operations, would pull people from other projects and would go about trying to get a minimum number of the very best people and put them on the project, give them minimal supervision, but let them trust them to be able to do the jobs that they're chosen to do.
After setting up the Skunk Works and recruiting his team, Johnson went to work on the P-80. Lockheed's contract with the Army Air Force gave him an incredibly short schedule, 180 days. Johnson went on a binge of designing and set his team to work on various critical paths and had the prototype ready for testing 37 days ahead of schedule. In 5 months, Lockheed had designed and built the first American jet. They hauled it from Burbank to Muroc Air Base in the California desert for testing. Fearful that there might be spies in the surrounding hills, they disguised the jet during transport with a plywood propeller. Johnson said years later that when he rolled out a new plane for testing, there was only one thing he thought about. What have I forgotten? In the case of the P-80, despite the short design and construction cycle, he hadn't forgotten much. It was a beautiful aircraft, faster and more agile than anything in the American arsenal. The war ended before it saw combat, but it evolved into the T-33, one of the best and longest-lived jet trainers in history. When the war ended, however, there were those who questioned whether the Skunk Works had a role to fill. After World War I, the business of aviation had shrunk almost to non-existent. After World War II, many people expected that it would again. But there were two basic differences between the ends of the wars. First, the United States was engaged in the world after World War II in a way it wasn't after World War I. No one could reasonably expect the world's only nuclear power to go back into hibernation. And second, before the war ended, it became clear that the post-war world would require a strong and ready military. Because on the day the Japanese surrendered, the world separated into two groups of allies, those in the communist East under the control of Joseph Stalin, and those in the democratic West. World War II was over, but the Cold War was just beginning. Kelly Johnson and the Skunk Works were just about to become the most important aircraft developers in the world. Over the course of his career, Kelly Johnson designed more than 40 aircraft. His most prolific period by far was in the 1950s. That was a decade of tremendous technological advance, achieved in an atmosphere of never-ending crisis. And there was no better place for aeronautical engineers to work than the Skunk Works. Johnson designed and built the Constellation, the most elegant aircraft of its time, and a plane that served effectively in both civilian and military roles. He experimented unsuccessfully with vertical takeoff and landing aircraft, with the idea that they could operate from relatively small ships. He designed the F-104 Starfighter, at 1,300 miles an hour, the fastest aircraft ever flown at the time. It was a sometimes fussy plane to fly, and at more than Mach 2, there wasn't a lot of room for error. It was adapted around the world to a number of difficult tasks, including carrying nuclear weapons. Johnson didn't approve of all the modifications others were making to his plane, but could do little about them. As the Cold War heated up, it became clear that the United States needed a way to peer deep into Russian territory. East of the Ural Mountains, where the Russians did their atomic research and where they developed their aircraft and missiles, the United States didn't even have an accurate topographical map, let alone a way of getting information on military capabilities. The Air Force put out a quiet request for a fast, high-altitude plane that could overfly Russia and bring back pictures of the communist secret bases. Johnson at first toyed with modifying the F-104, but it lacked the range and would be too difficult to fly on long missions. In 1954, he sent the Air Force a proposal to build a plane that could fly at a range of 4,000 miles above 70,000 feet. It would be slower than the Air Force had hoped, but at that altitude would be high above Russian air defenses. The Air Force didn't believe Johnson could do it. They doubted any jet engine would work at that altitude, and instead ordered a competition between manufacturers for the best biplane design. President Eisenhower approved a $35 million contract with the competition winner. Johnson and his Skunk Works team went into overdrive. In mid-November 1954, he met with a government advisory board on what was then called the CL-282 project. 10 days later, he formed the team to design the craft. On December 2nd, the first 12 engineers went to work designing the aircraft systems, and the first design drawings were completed and released to the shop for manufacture the next day. A week later, the drawings were complete, and by the end of the year, he'd won the contract and frozen the design. Wind tunnel testing completed in March, the first plane finished in July, and the first flight took place on August 4th, 1955. In less than a year, from pipe dream to first flight, Kelly Johnson and the Skunk Works had designed and built a completely new kind of airplane. The U-2 had something of a patched-together quality, to be sure. The first ones cut weight by leaving out the ejection seat, and the balancing wheels on the wings dropped off at takeoff to lose a few more pounds. The engineers were still making modifications on the craft in the summer of 1956, when a young pilot named Francis Gary Powers saw his first U-2 parked on a taxiway at a secret base in Nevada. It had not been built to last, he said years later. Powers was among the pilots who flew spy missions over the Russian heartland in the U-2, and for years it was safely out of range of the Soviets. The planes routinely returned with photographs showing Russian fighters 4 miles below them, coming up for a fight but unable to fly high enough to get a shot off. Eventually, however, the Russians improved their air defenses, and by the time Powers was shot down in 1960, Johnson was already at work on his next-generation spy plane. Johnson, with the U-2's flying with seeming impunity, had gone back to the government to propose a plane that could fly 10,000 feet higher and 4 times as fast as the subsonic U-2. Building a plane that would cruise at Mach 3.2, Johnson said years later, was the hardest thing the Skunk Works ever did. Everything about the plane, Johnson said, had to be invented. In 1960, the Air Force gave the go-ahead for Johnson to develop the A-12, a plane that didn't succeed as an interceptor, but paved the way for its slightly larger sister, the SR-71 Blackbird. Built out of titanium, which is light and could tolerate the 500-degree temperatures that built up as the plane sliced through the atmosphere at more than 3 times the speed of sound, the Blackbirds were like something out of a science fiction movie. The rollout was Johnson's proudest day. It was, he said, the smoothest test flight he'd ever been through. Johnson, who had never been much of a talker, insisted that he was not bothered by the fact that he couldn't talk about his perfect airplane. If I can talk about it, he'd like to say, it's obsolete. But years later, when word of the SR-71 had leaked out and the Air Force had stopped denying its existence, he took joy in its racing from New York to London, a distance of almost 3,500 miles in less than 2 hours. And before the Blackbirds were retired in March 1990, an SR-71 flew across the United States coast to coast in 68 minutes. Kelly Johnson retired from Lockheed in 1975. Even then, he was a presence at the Skunk Works. His 14 rules of effective program management are gospel there and are taught in some of the leading business schools in the world. Johnson even consulted with Lockheed during the development of the F-117 stealth fighter. As an old man, he said that there would come a time when aircraft were no longer relevant. People wouldn't travel for business, he said, because they could sit at their desks and talk to people in Europe by video phone. And on the battlefield, manned aircraft were no longer cost-effective in an age of missiles. Though it hasn't happened yet, don't bet against it.
I think his greatest contribution was in the vision that he had for the Skunk Works, for Lockheed, for American aviation, and in his ability to translate that vision into something that other people embraced and believed in and wanted to work toward. To a great extent, his greatest contribution was his ability to get other people to commit to his dream.
Kelly Johnson died just before Christmas in 1990.